Okay, so this is going to be a section, a little short video here on how to get little Sebastian, our little tiny test 3D printer on these parts, into the Dremel Digilab 3D slicer. So one thing that I'm having an issue with here slightly is that my computer has actually already selected the 3D printer I'm using. As you can see up here, the 3D printers we run around here at Spencerport are 3D45. Okay, so when you first open this piece of software, it's going to ask you if you want to set up a networked printer or a non-networked. You're going to hit non-networked printer, and then you're going to have to click on the 3D45 button. That just is the model we run around here. The other ones might work if you export the file, but to be safe, to make sure everything fits inside the build envelope and all those sort of things, we want to have the 3D45 selected. Once we have that done, we can come up here to open file, and we're actually going to find our STL file. As you can see here, I have a number of STL files of little Sebastian from my work here today. I'm going to select this one, no real particular reason, and here you can see that our model has appeared. Now, in order to move around in this environment, it is a little bit tricky. If you right-click on your mouse and hold, you can move around. If you use the scroll wheel on your mouse, you can zoom in and out. It's certainly not as nice and as smooth as Inventor in this regard, but it does work pretty well, and it allows you to get kind of some stuff figured out here. Now, to print little Sebastian, we want to have this square surface right here. We want to have that down on the build plate. So we have to rotate little Sebastian a little bit. And this is one thing this software does really, really well. Right here, you'll see what looks kind of like a nuclear cooling tower or something. We're going to click on that, and we're going to click on our part. So we click on our part first, I guess, then click on that, and now we're in business. So I'm going to use the red band here, and I'm just going to spin that around until it snaps. Now you can see I'm sitting down on the build plate nicely. Sometimes with really organic parts, it's never going to find a really good orientation with that. With that, you can click this lay flat button, and what it'll do is it'll take a part that might be a little bit off axis like this, and it'll find a flat-ish surface to lay it down on. This will be a better demo here. It really loves that axis. Let's try that. So now you can see it's kind of crooked. We hit lay flat, and it snaps it down to that surface. It's not perfect, but it's pretty useful. Let me get back to my good orientation here. One thing that is really nice is that it does a nice job of always keeping the bottom of your part touching the build surface. So there's that. Now, as you can see here with this red line, it's kind of yelling at us and saying, hey, this is going to need support. If I come over here, you'll see by default that generate support is already turned on. Okay, so that's really, really nice. With all that being said, we're pretty much ready to go here and print. A couple of things you might want to consider. One, make sure build plate adhesion is turned on. One of the biggest problems we have with 3D printing around these parts is the piece breaking off and not getting good grab onto the bed. Part of that is using the purple glue, especially on the Dremel printers. Other printers necessarily don't use that, but the Dremel ones definitely want some of that purple glue stick in the general vicinity of where you're printing. Additionally, getting that first layer of plastic stuck down is really important to getting the print started. So turning on build plate adhesion, usually what that's going to do is going to run a band of plastic all the way around your part, like a ½ inch away, and it's also going to add a little bit of a lip to this bottom surface. So there's that. We've got our infill set to 20%, and really there's not much reason to ever go higher than that. We could actually go significantly lower and still be okay, but 20% is kind of the sweet spot for like not too much diminishing return. We're not wasting a lot of plastic, but it's also nice and solid. There's actually some testing that suggests 100% is actually weaker than like 85 or 90%. So anyways, we've spent enough time talking about that. Again, support's going to support this side with the 90-degree corner. We actually don't need support on this side. I'm pretty sure it's still going to generate it, but kind of depends on what the settings are. There are some custom settings here, which occasionally we'll dive into to adjust things. The only real common one, especially on longer prints, is that we're going to turn our speed up. We've found a speed of actually about 120 millimeters a second works pretty well on most prints. On little Sebastian, it's tiny, really not a big deal. It's not going to take long to print anyways, so we're going to leave all these settings stock. Okay, without further ado, we'll take a look at our layers. Here you can see I can look at the different layers of our print by going to view modes, coming down to the layer setting, and I can start scrolling through. Oh, I haven't sliced it yet. My bad. So we're going to slice, and now I can come into layers, and now I can see the different layers we're going to be putting in there. So these little, it kind of looks like a frosting piped onto a cake or something. That is physically showing where the printer is planning on printing. So you can see here the support structure that it has generated to support this overhang, and the lack of support structure on this side, because 3D printers love curves. They hate 90-degree armpits like this. Okay. Some other things just to note, you can see it is printing a true circle. Earlier on, when we're exporting from CAD, we need to make sure we're not exporting a BREP image. We're exporting a high-resolution image. Sometimes you'll export as a BREP, and this will actually be like a hectagon or an octagon or some crazy pentagon with like a zillion sides. So that is that. We are ready to go. Without further ado, we're going to save the file. And what will actually happen is if you have a flash drive plugged into your computer. Can I have a flash drive? You got a flash drive back there, Philbo? Thank you, sir. Wow, this is a nice one. Is this gold plated? So I pop a flash drive in there, and it'll actually show up with this save to removable drive, which is a super nice feature. It automatically detects you've plugged something and is like, this is probably what you're going to want to put it on. So we can save to there. From there, you can take your flash drive out of your computer, go plug it into your 3D printer. You're going to find a button on the Dremel right in the middle. It says Build. You're going to hit USB. You're going to find your file, and you're going to get started. One thing that is important to note with the Dremel printer is you do not need to leave your flash drive plugged in for the duration of the print. As soon as you hit it, Build, and it starts that process, it's actually going to copy and paste your file in there. Okay? So, I wish you the best of luck 3D printing. If you got any questions, come find one of us. We'll be more than happy to help you out. That's it.